I got a doubt from one of my student, and the doubt is a circular loop of a string rotates about its axis on a frictionless horizontal plane at uniform rate so that the tangential speed of any particle of the string is v. If a small transverse distribution is produced at the point of the loop, with what speed will this disturbance travel on the string? So there is a loop and it is like rotating on a smooth table, and each point has tangential velocity v. So what is the process to solve this question? As we know, the speed of transverse wave on this string is how much? Root under t by mu, where t is the tension in the string and mu is the mass per unit length. So our aim is to find the tension in the string. To find the tension in the string, what we have to do? We have to take a small element of the string like this. Let this angle is theta. Then divide into two part. Then this one will be d theta by 2 and this part will be d theta by 2. Take this as a d theta, small angle. So this will be d theta by 2. Now, as it is rotating, so what will happen? That a centrifugal force, that is mv square upon r, will act outward. So same amount of force should be applied toward the center. So the tangentially the tension will be there, like, so T is the tension in the string. So one component of tension is how much? If see, this angle is d theta by 2, this angle will be also d theta by 2, and this angle will be also d theta by 2. The component of tension along this will be t cos d theta by 2, और इधर भी हमारा जो कंपोनेंट होगा टेंशन का वो t cos d theta by 2 हो जाएगा, एंड दिस साइड जो हमारा कंपोनेंट होगा t sin d theta by 2 हो जाएगा और ट्वाइस हो जाएगा, twice of this both. Now these two will cancel out and 2t sin d theta by 2 will provide the necessary centripetal force, that is, take this as dm v square upon r. Now our aim is to find the dm, that mass of this element, So d theta equal to how much? Dl by r, right? Dl is the length of this element. Then the value of dl equal to how much? R into d theta. And the mass of this element is dm. So dm equal to how much? Mu into dl. Where mu is the mass per unit length. Mu is here mass per unit length. Now the value of dl is how much? The value of dl is the dm equal to mu, and the dl is r d theta. Okay, now we will put in this, and for a small angle sine theta is nearly equal to theta, hence sine d theta by 2 is nearly equal to d theta by 2. So here 2t d theta by 2 is equal to dm is how much? Mu r d theta v square upon r. So after solving this r will also cancel out, this theta is cancel out, this 2 is cancel out, then the value of tension is how much? Mu v square. The value of tension in the string is mu v square. So the speed of the transverse wave is equal to mu v square upon mu. So it is root under v square, hence v. The speed of the transverse wave on the string is also equal to v. So the answer for this question is v itself. Okay, thank you.